next video is going to be all the formulas for the special quadrilaterals. This is what chapter 10 will be about. So that's what we're going to start right now in this video. Right now in your ISN, you need to put in your table of contents, page 64, chapter 10, extending perimeter and circumference and area. This is just a title page. You can create a chapter 10 tab on page 64. On page 65, this is where formulas for special quads are going to go. So these are where all your notes for today's video is going to go in your ISN. Again, I've made notes on the slide what needs to go in your ISN and what doesn't. And notes need to be written thoroughly, and all examples need to be in the notebook. For this actual video, there will not be any examples. We'll do the examples on Monday, but you do need to know all of those formulas. When we go through these topics and these formulas, I would suggest that you also draw the diagram so you know what you are referencing to when we have these formulas and what means what. So the first one is a parallelogram. The area formula, where does it come from? I had a demonstration, but on this computer I don't have Java, so it will not work. What's happening is you are provided a parallelogram right here. In that parallelogram, you can slice it and create a height in that. That height has to be equal, or has to be a perpendicular angle, or at a 90-degree angle. If we take that parallelogram and we split those two pieces apart, which happens to be right over here, I now have what looks like a trapezoid and what looks like a right triangle. If we rotate that right triangle around or slide it around, we can actually create a rectangle. This is something that you should already know how to find the area of. How do you find the area of a rectangle? Well, that's just base times height, or length times width. So the parallelogram is very similar to what you will see with a rectangle when it comes to area. So here is the formula you need to have written on page 65. Again, I would suggest that you draw the diagram just so you know what you're referencing. The area of a parallelogram with base B and height h is A equals B times h. Pause the video, write the formula, and draw the diagram, and then keep moving on. The next one is area of a triangle. Most of you already know the area of a triangle. The area of a triangle is 1/2 base times height, or BH divided by 2. There are multiple triangles that you can find the area of. Sometimes that height is going to be inside your triangle. That's if you are given an acute triangle, and that's what's shown to you on the screen right here. Sometimes you're going to be given a right triangle, and when you're given a right triangle, your base and your height are just the legs of your right triangle. And when you're given an obtuse triangle, the height is actually outside, and we've talked about that in class too. Take a minute, write the formula, and draw the diagram on page 65 for your ISN, and when you're done, go ahead and move on in the video. The next one is a trapezoid. I do have a demonstration for this one. What you see here on this screen is a trapezoid. It has two bases, B1 and B2, and it has a height of h. If you click run, this is actually what we're going to do is we're going to make a copy of it. When we make it a copy of it, we can actually rotate it 180 degrees and translate it over to the other trapezoid. What's happening is it's becoming a parallelogram. And you already know how to find the area of a parallelogram. It's base times height. Now in this case, we have base 1 and base 2. That is the whole base, so that's why we added them together, and the whole height is h. Well, if we were to find the area of a parallelogram, we would do B1 plus B2 times h. In this case, if you look at your diagram, we have an orange trapezoid and a yellow trapezoid. We don't want both of them. We want the area of just one of them, and so that's why we have to cut it in half. So if you go back, let's run this one more time. You can rotate another trapezoid, and they can slide together. And when you do that, you can combine your bases to have B1 and B2. And then when we combine them, we also have a height of h. That height is going to stay the same for that trapezoid because we're just rotating that original trapezoid around. So again, when we find the area of a parallelogram, we just did base times height. and our base was b1 plus b2, and our height was h. So we're going to multiply those together, and since we only want the area of one of them, we're going to cut it in half. So let's go back to our notes. Here is the area of a trapezoid. We're just going to take our two bases, add them together, multiply by our height, and then divide by 2. Take a minute, draw the diagram, write the formula down on page 65, and then continue with the video. The next one is area of a kite. If you know the lengths of the two diagonals, which in our diagram is B and A, the area is going to be half of the product of your diagonals. So you're going to take D1 and D2, multiply them together, and divide by 2. Draw the diagram, write the formula down, and go ahead and move on with the video. Area of a rhombus is the same exact thing. It's just the same formula for your kite. You're going to take your two diagonals, B and A in that diagram, and you're going to multiply them together and then divide by 2. So draw your diagram, write your formula down, and then move on with the video. Next one is circumference of a circle. Most of you remember this from middle school. We've kind of used it this trimester already, or this year already. We used it in the first trimester. The circumference can be either diameter times pi. Remember, diameter is the whole length of the circle. And you could also use the other formula, 2 pi r. 2 and r represents your radius, and radius is going to be half of your diameter. So take a minute, draw your diagram, write both of those formulas down on page 65, and then continue with the video. And the last one is area of a circle. Area of a circle, again, is just going to be using your radius. So radius is half of your diameter. When you find the radius, you're going to take pi and you're going to take r squared. Do not multiply radius times pi and then square it. That's not what the formula says. It says take your radius, square it, then multiply by your pi. Again, we've used this pretty much all year, so it shouldn't be anything new. Go ahead and write this formula down again on page 65, draw your diagram, and continue with the video. Last but not least, again, you'll have a quiz on Monday. I talked about this on Friday. You need to be prepared. There will be a quiz over everything that we've talked about in these videos, both of them, the trapezoid mid-segment theorem and the formulas. Bring any questions for me on Monday, and then on Monday in class, we'll start putting these formulas to work.